Hello students, I am Ashish De. In my earlier video, I have taught the topic delta modulation. Now, I will teach the topic adaptive delta modulation. Okay, so reason to use adaptive delta modulation. To overcome the quantization errors due to slope overload and granular noise, the step size delta is made adaptive to variations in the input signal xt, particularly in the step segment of the signal xt. The step size is increased. Also, if the input is varying slowly, the step size is reduced. Then this method is known as adaptive delta modulation. The adaptive delta modulators can take continuous changes in step size or discrete changes in step size. Now, transmitter part. So, transmitter of adaptive delta modulation. Transmitter part of adaptive delta modulation. The block diagram for the transmission part of adaptive delta modulation consisting of 3 units: logic for step size, control. So this is one part. Another part is 1 bit quantizer. Another part is delay unit. Delay time is TS, one sampling period, right? Now there are two summer. Here is another summer. So this is summer. This is the output of ADM, adaptive delta modulation. Okay, and here is the input. So here is the input x of NTS is the input, and this is a negative feedback. Okay, here is the error signal E of NTS, and this is the measure value of XNTS. Okay, and this is U of n minus 1 into TS. This is UNTS. Okay, now this unit is this portion is called accumulator. Okay, and this is basically a summer consisting of this is UNTS, right? Now this is the transmitter block diagram for the transmitter part. The logic for step size control is added in this diagram. Okay, that's according to a specified role depending on 1 bit quantizer output. As an example, if 1 bit quantizer output is high, then step size may be doubled for next sample. If 1 bit quantizer output is low, then step size may be reduced by 1 step. Figure shows the staircase from adaptive delta modulation. The receiver part of adaptive delta modulation. Receiver part consisting of logic for step size control, so the same unit, logic unit, is here as in transmitter section. So this is receiver section. Okay. Now here is a mixer, here is the input. Okay, here is the delay unit of delay time TS. Here is positive feedback. And there is a low pass filter or LPF. Low pass filter is here. Okay, so this is the output of the receiver section. This is the output, and here is the input section. So this part is basically accumulator section. This part is accumulator. This is accumulator. Okay. There are two portions. The first portion produces the step size from each incoming bit. So this portion, the first portion produces the step size from each incoming bit. Exactly the same process is followed as that in transmitter. The previous input and present input decides the step size. It is then applied to an accumulator, which builds up staircase waveform. The low pass filter then smoothens out the staircase waveform to reconstruct the original signal. Okay, so this is the receiver part and this is the transmitter part for adaptive delta modulation. Now, advantage of adaptive delta modulation. Adaptive delta modulation has certain advantages. The signal to noise ratio becomes better than ordinary delta modulation because of the reduction in slope, overload, distortion and ideal noise. Because of the variable step size, the dynamic range of adaptive delta modulation is wider than simple delta modulation. Utilization of bandwidth is better than delta modulation. Okay, so these are the three advantages of adaptive delta modulation.